Have you ever noticed how an AI like ChatGPT can feel so incredibly smart, but then you ask it about something that happened yesterday or about your company's latest internal report, and it just draws a blank? It's like it has this giant, brilliant brain, but it's missing a key part, the ability to learn about your world right now. So how do we fix that?
This is the central question for thousands of companies right at this moment. How do you take one of these powerful large language models and give it a real understanding of your internal documents, your customer data, your unique corner of the universe, and do it without spending a fortune?
You hear this idea thrown around all the time. It sounds so simple, doesn't it? Just feed the AI all of our PDFs and documents, and boom, instant expert. But, well, it turns out it's not easy at all. In fact, that whole approach is basically a non-starter.
So, to really get this, we've got to break it down. We're going to start with what I call the LLM's blind spot. Then, we'll dive into a totally new way of thinking about searching by meaning. We'll uncover the magic of something called embeddings, check out the special libraries built to handle them, see how it all clicks together in a process called RAG, and finally, take a peek at the future this all unlocks.
Okay, first things first. Let's tackle why that just trained it idea is a dead end. It all comes down to a fundamental limitation, this blind spot that's built right into every large language model.
Here's the deal. Models like GPT are trained on a massive but frozen-in-time snapshot of the public internet. They literally have a knowledge cutoff date, so they're completely clueless about anything that's happened since. But even more important, they have absolutely no idea what's in your private company files. And while you might think, can't we just retrain it, the cost is astronomical. We're talking millions of dollars, way out of reach for almost everyone. Even a cheaper method, fine-tuning, is really more about changing the AI's personality, not about teaching it new facts.
All right, so if we can't just stuff more knowledge into the model's brain, we need a smarter approach. And that means we have to fundamentally shift how we think about search, moving from just matching keywords to actually understanding concepts.
For decades, search has been all about keywords. You type car, you get back documents with the word car. It's super literal, super rigid. Semantic search is a completely different ballgame. It searches for meaning. You could search for automobile or family vehicle, and it could find documents that only mention cars because it gets the idea behind the words, not just the letters themselves.
And this is the classic example of where the old way just falls flat. An employee asks a totally normal question. What are the clothing rules? A keyword search comes back with nothing, 0 results. Why? Because the official HR handbook uses the phrase dress code. The computer fails a common sense test that any person would pass in a heartbeat.
So how in the world do you get a computer to understand meaning? The secret sauce is a piece of machine learning magic called embeddings. This is the key that translates our messy, nuanced world of language into the clean, simple world of numbers that computers absolutely love.
So what is a vector embedding? At its core, it's just a long list of numbers, but it's a very special list of numbers that acts like a mathematical fingerprint for a piece of data. Doesn't matter if it's a word, a whole paragraph, or even a picture, an embedding model can turn it into a vector that captures its essential meaning.
The best way to think about these vectors is as coordinates, like GPS coordinates for ideas in a giant, invisible space. Things with similar meanings get mapped to points that are really close to each other. So the vector for holiday is numerically almost identical to the vector for vacation. But the vector for work? Yeah, that's mapped way over in a completely different neighborhood of this idea space.
Okay, so now we can turn any concept into a special numerical coordinate. We need a place to put all of them, a kind of high-performance library built just for these ideas. And that, my friends, is where vector databases come into the picture.
A vector database is a special kind of database. It's purpose-built for one job and one job only: finding the nearest neighbors to a query vector and doing it at lightning speed. You give it the vector for clothing rules, and it can scan its entire library and instantly tell you the closest match is the vector for dress code.
And it's so much more than just a place to dump numbers. A real vector database is a full-on management system. It doesn't just store billions of these vectors, it also keeps track of all the original data they're linked to. It uses really clever indexing algorithms to make searching ridiculously fast. And it's designed from the ground up to handle massive datasets, calculating the distance between vectors to find the best matches in the blink of an eye.
Okay, we've got all our pieces on the board. The LLM with its blind spot, the concept of embeddings, and the vector database to store and search them. Now let's put it all together in a system that actually solves our original problem. It's a process called Retrieval-Augmented Generation, or RAG for short.
And this is where it all just clicks. Here's the play-by-play. First, a user asks a question. That question gets turned into a vector. That vector is sent to the database, which instantly finds the most relevant snippets of text from your private documents. Now, and this is the genius part, that retrieved text is taken and combined with the original question to create a new, supercharged prompt. Finally, that prompt is sent to the LLM, which can now generate a perfect answer that's grounded in your specific, private data. And just like that, the AI's blind spot is gone.
So this is obviously a complete game changer, but its impact goes so much further than just building smarter chatbots. We are really watching the beginning of a brand new era for how we find and interact with information.
This technology is already all around us. When Netflix or Spotify recommend something based on the vibe of what you just watched or listened to, that's vector search. When you can search your phone's photo library for beach without ever tagging a photo, that's vector search. It's being used right now to detect financial fraud, to find crucial patterns in genetic data, and it's the engine behind the next generation of e-commerce.
All of this leaves us with one really fascinating final question. For the very first time, we have the power to search not just for words on a page, but for meaning itself, for concepts, for relationships, for ideas. So what new discoveries will this unlock? What hidden connections are we about to find? And what incredible questions that we once thought were impossible to answer can we finally start to ask?